Okay, we will go through the exemplar questions in the class 11 chemistry, first chapter, basic concepts of chemistry. So before going through it, I will show you how to find the number of significant figures. Okay, that will be useful. So here 846, there are 3 significant figures, and 704 here also 3. So here we have 4 significant figures, but here you see 500 we have only 1 significant figures. That is trailing zeros. If you don't have a decimal point, then you have to discard this 0. So 500 without decimal point, only 1 significant figure. 500 with decimal points, we have 3 significant figures. 500.0 will have 4, and this 0.075 only 2. We have to discard these leading zeros here after decimal point, these leading zeros. 0. So here in this case we have 5. So here you see without decimal point we are discarding this 0. So 3. Here also 3. So here there is a decimal point 0. 1, 2, 3, 4, 5. Okay. So here after 0 we are having 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. See 100 we have only 1. 1 into 10 square if you write that also 1. But 1.0 into 10 square you have 2 because there is a decimal point. 1.00 into 10 square there are 3. Okay. So you have to see whether decimal point is there or not. Trailing zeros without decimal point and 0 after the decimal point. So these things you have to take into consideration. So when you do multiplication, 2 number, you have to, this is minimum number of digits here. Here 2 significant figure, here 3. We have to, the result should have only 2. Okay, this is the result, and the only 2 significant figures are there in this. Okay, 2 students, they are performing some experiments separately. Each one of them they record the results, correct reading. The correct reading is 3 gram. On the basis of the given data, mark the correct option. Okay, so here, okay, one person record 3 okay, the other person record. This is not precise because the precision and accuracy. So here between these 2 readings there are a lot of deviation is there. So this is not precise. So among these answer, results of student is both precise and accurate. So the accurate also, precise also, because between these 2 readings the difference is 0.02 only. They are close to the actual reading of 3. So this is precise as well as accurate. So in book page number 13, see they are given these readings. Okay, you can go through it. The reading C is precise as well as accurate. Okay, so what is precision, what is accuracy, they are given here. Measured temperature, Fahrenheit scale is 200 Fahrenheit. What will be the reading in the Celsius? Okay, we have to use the conversion formula, Fahrenheit Celsius conversion formula. Okay, it is given here, so you can use this formula to convert. After conversion is here. What will be the molarity of the solution which contain 5.8 grams of the NaCl per 500 ml? Okay, see molarity is number of moles of the solid divided by the solution in liter. Okay, volume of the solution in liters you have to see. So here molar mass of NaCl. See how to compute molar mass. If you say atomic mass, then add these Na and Cl atomic mass total 58.5, then you have to simply put the gram next to that number. So that is the molar mass. So they are given 5.8 grams of the NaCl. So how many moles from this? This is 0.1 mole, because 1 mole is 58.5 gram. They are given 5.85 gram. Okay. So that is the mole, and 500 milliliter, that is 0.5 liter. Okay, using that you find the molarity. Okay, number of moles of the solid divided by volume of the solution in liter. 0.5 mole, how it comes? Because 1 mole is 58.5, but we are using only 5.85 gram, 1/10 of the mole we are using. So this is 0.1 mole. Okay, the molar mass is just put the gram is here. Next to the atomic weight you just put gram, then it will become molar mass. So NaCl, Na plus Cl. Okay, then you divide by volume in liter, that is 500 ml they are given, so that is 0.5 liter. Okay, this is the answer. 500 ml of 5m molarity solution, 5m solution is diluted with 1500 ml. What will be the molarity? Okay, 5m means there are 5 moles in 1 liter. Okay, 500 ml. So if you take only 500, then it will be 2.5 moles on that. So when you 2.5 moles, if you dilute, the totally 2.5 moles, and the volume of the solution 1.5 liter, that is 1500 ml. So 2.5 moles the molarity, 1.5, this is the answer. So that molarity definition is given in the book in this page. So here this is a molarity definition. See, the number of atoms present in 1 mole of an element is equal to the Avogadro number. Okay, that is the information. Which of the following element contains the greatest number of the atoms? Okay, so here you have to take the molar mass. Okay, so now the helium, sodium, calcium, helium. Okay, so here this is one. Helium is the atomic weight of 4, so that is molar mass of 4 gram. And sodium, that is 23, so here 23 gram, so that these two, what is in 2 moles. So here this is 0.01 mole, because calcium is 40 gram. So here we have 3 mole, and this 3 mole into the Avogadro number. So you will have the maximum, which of the element contain greatest number of atoms. So these 3 moles is there. 1 mole will have the Avogadro number of the atoms. So this will have the more number of atoms. Molar mass. Okay, and okay, so 4 gram of helium have 1 mole, because the 4 gram molar mass of helium, and 12 gram will have 3 mole, and 3 into 6.022 in 10 power 23 is the Avogadro number. Okay, so this will have the highest number of elements. If the concentration of the glucose in the blood is this, what will be the molarity of the glucose in the blood? Okay, so this is the molar mass, 180 gram. 180 gram, the weight is given 0.9 divided by 180. in 1 liter. So this is the molarity. What will be the molality of the solution containing 18.25 gram HCl gas in 500 gram of water? Okay, what is the molality? Number of moles of the solute divided by the weight of the solvent in kilogram. Okay, number of moles of solute divided the mass of the solvent in kilogram. This is different from the molarity. Okay, so number of moles is 0.5 and this 500 gram is 0.5 kg. Okay, this 1 m is the molality. Okay, see how in the book. Okay, solid HCl 500 gram, that is 0.5 kilogram. Okay, 18 HCl gas. Total 1 mole is this 36.5. Okay, 1 mole. So we have 18.25, that is 0.5 mole. That is equivalent to 0.5 mole. 0.5 divided by 0.5 kg is 1 m. One mole of any substance this is the Avogadro number. The number of molecules of H2SO4 present in 100 ml of the 0.02 m H2 is 1 liter. 0.02 m means 1 liter will have 0.02 moles. Okay, 100 ml will have again this will be 0.002 mole it will be having, because 1 liter will have this mole means 100 ml will have this. Okay, then this many moles into the Avogadro number, the number of molecules present. Okay, number of molecules, this many moles in the Avogadro number. Okay, this is the one. What is the mass percentage of the carbon dioxide? Okay, carbon dioxide to CO2 12 carbon and this atomic mass of carbon is 12 and O2 is 32. The total is 44 gram is the molar mass, and carbon divided by 44 will give carbon mass percentage. What is the mass percentage of the carbon and they are asking? Okay, so carbon is 12 divided by 44. The empirical formula and molecular mass of a compound they are given. Okay, what will be the molecular formula of the compound? Okay, this is the empirical formula. Carbon 12 plus 2 plus 16, we have 30 empirical formula, but molecular mass they are given 180, so this is 6 times, the ratio is 6 times. So this formula CH2O in 6 times means C6He12, He2 into 6, then O6, then this is glucose. Okay, this is the molecular formula. What will be the molecular formula? If the density of the solution, they are given density mass of the 1.5 ml solution in significant figure. They are asking this mass equal to density into volume. Here you see 3.12 into 1.5. This is least is only 2 significant figure. 1.5 having only 2 significant figure. The result also should be having 2 significant figures only. Okay. And the multiplication page 13. So they given what is the rules, how many significants should be there when you multiply two number. You have to take the least. Here 2.5 is the least, like that. So that is the result. This will have this is having two significant figures. Which of the following statement above the compound is incorrect, they are asking. So there are correct statement also is there, incorrect. So you read all the point. A molecule of a compound have atoms of different elements. Okay, this is correct. So they are asking what is incorrect. A compound cannot be separated into constituent atom by physical. No, it cannot be by chemical methods only you can separate. Okay. So this is also correct. They are asking what is not correct. A compound retains the physical properties of its constituent atom. Okay, this is incorrect. The ratio of the atoms of the different elements in a compound is fixed. Okay, this is correct. Okay, this what is this compound properties is given page number 6. So what is a compound and what is property they are given here. Okay. Which of the following statement is correct about the reaction is given? They are given this reaction. The total mass of the iron and oxygen in the reaction is equal to total mass of the iron and the oxygen in the product. Reactants equal to total mass in the products. Therefore, it follows the law of conservation of mass. Okay, 21. Okay, according to the law of conservation of the mass, the balance. Okay. The total mass of the reaction is equal to total mass of product. Therefore, law of this is iron and oxygen in the reaction. Total mass of the iron and oxygen in the product. Okay, this one is correct. Amount of can be increased by taking any one of the. Okay, no. This is the correct answer. Which of the following reaction is not correct according to the law of conservation? Which of the following reactions? So this is not balanced. Okay, it has to be balanced. Not balanced. 21. Just I showed you. Which of the following statement indicate the law of multiple proportion is being followed? Okay. Sample of carbon dioxide taken from any source will always have carbon and oxygen in the ratio 1:2. Which of the following statement indicate law of multiple proportion? Okay, carbon forms two oxide, namely where masses of the oxygen which combined with the fixed masses of the carbon are in the ratio 2:1. Okay, this one is the correct. 15. Law of multiple proportions. Okay, so you can go through this how they explained. Multiple choice questions. 1 mole of oxygen gas at STP. So whichever gas has STP will have the Avogadro number of molecules. Okay, so 32 grams of oxygen. Okay, this is the molar mass of oxygen. Okay. Sulfuric acid reacts with the sodium hydroxide in the formula. When 1 liter of the 0.m sulfuric acid solution is allowed to react with the 1 liter of the 0.m sodium hydroxide solution, the amount of the sodium sulfate formed and its molarity of the solution. 17. Okay, sulfuric acid, this is 1 mole reacts with the 2 moles of the NaOH, but they are given 0.1 mole of the H2SO for point, but we require 2 times H2SO for 1 mole means we require 2 mole of NaOH, but they given only, so 0.1 mole of the NaOH will react with only 0.05 mole of H2SO4. So NaOH is a limiting reactant here. Okay, so we do not use the complete 0.1 mole of H2SO4. So H2SO4, so this will be equation 0.05 mole of H2SO4 plus 0.1 mole NaOH. Okay, this will be, now the molar mass of Na2SO4 is 142. So, but we have 0.05 mole of the Na2SO4. So, this will be, the result will be only 7.1 gram only. Okay, because of that limiting reactant. So, from that we can find out the what is the molarity. Molarity only. To volume of the solution in liter, we have 1 liter of this and 1 liter of this. Okay, so this is the molarity. Okay, this is the weight of this product and this is the molarity. Which of the following pairs have the same number of atoms? Okay, this is 2 moles each. This is having 2 moles, this is 2 moles, this is 1 mole each. Which of the following solutions have the same concentrations? Okay, 20 gram of NaOH, that is 40 gram is the molar mole, we have 20 gram only, so we have 0.5 mole of this. So 0.5 mole in 200 ml is also 0.5 mole in 200 ml. Okay, 16 gram oxygen have the same number of molecules as, okay, 16 gram oxygen is 1 mole. This is also 1 mole for nitrogen, this is hydrogen for 1 mole. Molar mass of this. Which of the following terms are unitless? Mole fraction is unitless, mass percentage is unitless. One of the statements of the Dalton's atom theory is given below. The compounds are formed when atoms of the different element combine in a fixed ratio. Which of the following there are, which is not correct? Okay, law of conservation of the mass, that is not correct. Balancing equation, which of the following is not correct to this statement? Okay, Avogadro's law. This is mole. Okay, short answer type. What will be the mass of 1 atoms of the carbon 12 in grams? Okay, this is 12 into 1 atomic mass unit. 12 into 1 atomic mass unit. That will come this. I will show you in the book. Okay, 1/12 of the mass of the carbon 1 atomic unit. So 12 into 1 atomic unit. 1 aim is 12 into this, you will get that answer. This one. Okay. How many significant pairs would be present in the following? So here this is minimum, because this is multiplication division, minimum 2. So 13. The answer is 2. 13 in the book they given how many significant figures should be there while doing the multiplication here. They are given the rules here. what is the symbol of the SI unit of the mole, how the mole is defined. Okay, mole is mole only. 1 mole is defined, this is the amount of the substance that contains as many particles or entities as there in the atoms, exactly 12. This is the carbon 12 isotopes. Here which page? 16. Okay, they are given here. This is the reference. What is the difference between the molality and molarity? Okay, molarity is moles of the solid divided by the volume of the solution in liter, and the molality is moles of the solid divided by the mass of the solvent in kilogram. Okay, 26. So here this molality is the number of moles of the solid present in 1 kilogram, that is molality, but molarity is the number of moles of the dissolved in 1 liter of the solution. So the molality is independent of the temperature, whereas molarity depends on the temperature because it depends on volume. Molarity is temperature dependent. Calculate the mass percentage of these things. So 27. Okay, this total mass divided by the molecular mass they are computing. So you can go through it. See in book 23, book page 23. So this problem is a similar problem, mass percentage, how to compute, they are given the details here. .45 liter of the dianitrogen reactor with the reagent what is formed, the reaction is given. Okay, which law is being obeyed in this experiment? Write the statement of the law. 28. According to the Gay-Lussac's law of the gaseous volumes, gases combine or are produced in a chemical reaction in a simple ratio by volume, provided that all the gases are at the same temperature and at the STP, same temperature and pressure. Okay, 28. Page 15. Okay, this is the one. Okay, observe that this is the law is given, so you can go through it. If two elements can combine to form more than one compound, the masses of the one element that combine the fixed mass of the other element are in the whole number ratio or in 29. Is statement true if yes, according to which law? Give one sample. Law of multiple proportion. 29. According to the law of multiplication, they given hydrogen and oxygen. Here we are adding 16 gram, the output 18 gram. Here 32 gram, the output is 34 grams. Okay. So here the masses of the oxygen 16 grams in H2O and 32 grams in H2O, which combine with the fixed masses of the hydrogen. Hydrogen is fixed, only oxygen is varying. Oxygen varying in the simple ratio, so the output also is reflecting in it. In the 15 also similar. They are given here. Okay. Calculate the average atomic mass of hydrogen using the following table. Okay, average atomic mass of the hydrogen 30. Overall mass they are given average atomic mass. How to compute it? Okay, you can go through it. That is also given in the book page 17. Average atomic mass. Average atomic mass. Okay, so how to compute it? They are given here. This sample. Hydrogen gas is prepared in the laboratory by reacting with the HCl. Okay. Following the reaction takes place. Zinc plus HCl, zinc chloride. So calculate the volume of the hydrogen gas liberated as the STP. When this many gram of the zinc reacts with the HCl, 1 mole of gas occupies 22.7 liter of volume of steam. Okay, this is important information. Atomic mass also they are given 31. From the equation, 63 gram of the zinc evaporates this much. So how many moles? And this is the molar mass they are given. Atomic mass. Okay. And this many liter. Okay. The density of the 3 molar solution of NaOH is given. Calculate the molarity they are asking. Okay, molarity. 3 molar solution of NaOH means 3 moles of NaOH are dissolved in the 1 kilogram, that is 100 gram of the solvent. So this is the meaning. 3 molar solution means 3 moles of NaOH. Okay, molality, moles of the solute divided by the mass of the solvent in kilogram. So mass of the solution is the mass of the solvent plus mass of the solute. Okay, they are computing the mass and the volume of the solution. Computing volume equal to mass into density. Density is given. Since 100 of the solution 3 moles. Okay, 3 moles divided by the volume of the solution in liter. This will become the molarity. Important I put because 3 molar solution means what is you have to understand. That is important. Volume of the solution changes with the change in temperature. Then will the molality of the solution, molality is independent of the temperature. Give the reason for your answer. 33. Molarity of the solution does not change with the temperature since mass remains unaffected with the temperature. Because molality is moles of the solute divided by the mass of the solvent in kg. So mass unaffected with the temperature. 4 gram of NaOH dissolved in calculate the mole fraction of the component of the solution. Also determine the molarity of the solution here given the specific gravity. So using specific gravity, how to find the volume? That is why I put this important 34. So okay, mass of the NaOH, number of moles. 40 gram is the molar mass of NaOH. So 4 gram is 0.1 mole. Mass of this water is this much. So this is 2 mole. Mole fraction mole fraction of NaOH. Okay, mass of the solution is water plus NaOH, total mass. Volume of the solution, here they are using the specific gravity. Okay, that is why I put important. Then from that molarity they are computing. The reactant which is entirely consumed in a reaction is known as the limiting reaction. So this is important. Okay, so they are giving what is limiting reaction. The reaction which is entirely consumed. Okay, in the reaction 2A plus 4B only, when 5 moles of A react with 6 moles of E. Okay, if 5 moles, if we are taking A 5 mole means we need 10 moles of B, because 2A 4B. Okay, 2 times so, but they are saying only 6 moles is there. Then visit the limiting reactant, calculate the amount of the C formed. Okay, according to the 2 moles of A requires 4 moles, double the thing for the reaction, but we have 5 mole means B required is 10 moles we require, but we don't have 10 moles, but we have only 6 moles of B. Hence B is the limiting reaction. So the amount of C formed is determined by the since the 4 moles of B gives 3 moles of C, here 6 moles of B is okay. This is the answer. Matching type. This is CO2. This is 2 moles of CO2. That is 44. 1 mole is 44. 6. This is 1 mole. Okay, this is the Avogadro number. 5.6 liter of O2 at STP. At STP 0.25 moles. Okay, 90 gram O2 3 mole. 1 mole of any gas. Okay, so 1 mole means this is Avogadro number of molecules. Molarity unit is moles per liter. Mole fraction, that is unitless. Mole means mole only. Molality means mole per kilogram. Pressure, Pascal and Newton per meter. Luminous intensity is candela. Density, gram per milliliter. Mass, kilogram. Assertion, the empirical mass of the ethane is half of the molecular mass. The empirical formula represents the simplest whole number ratio of the various atoms present in the compound. Okay, both here are is the correct expression. What is empirical formula and molecular mass given here? Empirical formula, how to compute this molecular formula, and you can go through these problems also. One atomic AMU is defined as the 1/12 of the okay, this is correct. Carbonyl isotope is most abundant as both A and true, but the R is not the correct explanation of the A. Significant figure for 0.200 is 3, whereas for 300 is 1, because the significant differs whether we have a decimal point or not. 0 at the end or the right of a number are significant provided they are not on the right side of the decimal thing. I guess A true, but reason is not correct. This is correct. 3 here, this 3 significant, this is 1, but the reason is not correct. Combustion of 16 gram of the methane gives 18 gram of water. No, that is wrong. In the combustion of the methane, water is one of the product. B is true, but A is wrong. Actually, it gives, that is 2 moles of water. Combustion of 16 gram of methane gives about 22. See here, this is the combustion reaction. Long answer types. So this is using Boyle's law, but that law is not there in the book. But anyway, you can go through the answer 42. So they are given P1 V1 equal to P2 V2. How to find all those things? Calcium carbonate reacts with the HCl gives CaCl2, and this is the reaction. What mass of CaCl2 will be formed when 250 ml of 4.5 reacts with this? This is also like a limiting reagent only. I already seen one example, 43. Okay, they are computing, and so we have only this many moles, hence HCl is a limiting reaction. So the final output mass is this much. Define the law of multiple proportion. Explain the 215 is already explained. Law of multiple proportion. Okay, they are given examples also here. So this law of multiple proportion also you can go through it. Okay.